If you click this video away, then please tell me what the reason was so that I can improve. Otherwise, hi and welcome. I'm trying to learn electrical engineering today, electric generators, and after we've done it, we're going to do standing yoga. And if you participate in the standing yoga, that is what it is. Coming back to our main theme in this book, that of electrical energy, it is now advised to think about the energy changes involved in electromagnetic induction. So the energy changes. A transformator, in a sense, converts electrical energy into magnetic energy and back again into electrical energy. Quite often what is required is to change mechanical energy, kinetic energy of motion, into electrical energy in a device called a generator. Our previous experiment, which involved moving a magnet with respect to a coil of wire, indicates how this energy change can be brought about. An induced current can be created by the movement of a conductor in a magnetic field. Inducing a current, we didn't really understand that it has something to do with the lines of force of a magnetic field are crossed, and that leads to having the opposite charge on the other side. Some type of electric is induced on the other side. So a magnet has the lines of force around it, and these lines of force are crossing then the electric lines of something else. And in that moment there is this induction happening, which I don't understand already with the word. There's electricity inducted, I don't know. And now when it's crossed, that is induction. And that is the idea. So we're having our kinetic, mechanical engine energy, we're having a magnet or something turning, and we're having something around, but I think we're going to have something better in a moment. And that magnet has its magnetic field lines around it, and they are crossing the electric field lines of a wire twisted around it, coiled around it, or whatever, spun around it. And every time they're crossing, there is electricity induced. So we're having, what we're saying is, in a sense, converts electrical energy into magnetic energy and back again into electrical energy. There's the electric energy on the wire, the magnetic energy is the magnet, and it's crossing the magnetic field, are crossing the electromagnetic fields, and in that moment electricity is generated. But we don't understand it. Also how it's there. The diagram shows a single coil of wire. I don't even know the words. What is a coil? What is a wire? And so on. I think the wire is the cable, and the coil is the thing twisted. A diagram shows a single coil of wire being rotated in a magnetic field. This field exists in a gap between the two pole pieces, which in a practical form of generator will be the poles of an electromagnet. I think I explained the whole time the other way. The magnet is at the outside and the wire. It can be the other way around. The magnet, the outside, the wire. Let's do it. This field exists in the gap between two pole pieces, which in a practical form of generator will be the poles of an electromagnet. As the coil rotates, a current is induced in it and is led away from the generating coil via two rings which rotate with the coil. These are called slip rings. Where are the slip rings? There's slip rings. So the coil is turning, and there are the two magnets at the outside. Pressing against these by springs are blocks. Pressing against these by springs are blocks of carbon called brushes. They are brushes out of carbon. That is better, whatever it is now. The current produced alternates at each side of the coil, goes up through the magnetic field, then returns down through it, and so on. That thing looks like a rudder, or is it even called rather an orb where people are rowing? Is it a fixed piece, or is it the coil and it's just the one coil outside with thin piece and in the middle is nothing? I don't know what a coil is. The current produced alternates on each side of the coil goes up through the magnetic field, then returns down through it, and so on. So here is a simple alternating current generator, usually called an alternator. In practice, an alternator will have not one but many turns of wire in each coil, and several coils, not merely one. Okay. It is a single one of wire, and normally there are many of them. You may remember what we said on page 44, that magnetic lines of force travel more easily in iron than in air, so you will appreciate why the coils of a generator are wound on an iron core. Okay. So we're having our wire and we're coiling it. What is it now called? Why the coils of a generator are wound on an iron core. So the coils are wound on. Now, on a magnetic core, because when the magnetic field, which is through the coil coming, goes easier through the iron core, because the iron is easy to magnetize. This kind of arrangement, shown in figure 41, gives some idea of how the magnetic circuit is arranged, so that the coils of wire move in a small air gap between the outer stationary part, stator, and the moving inner part, rotator. Figure 41. How the magnetic circuit is arranged so that the coil of wire move in a small air gap between the outer stationary part. The coil of wire move in a small air gap between the outer stationary part. Maybe it's this little air. The rotating coil assembly is called the armature, and it is in the armature coils that the current is produced. So here's the current induced, produced. There are three important points which arise in connection with generators which must be understood. Eddy currents. Not only do the coils of wire rotate in a magnetic field, but the core itself does so. And currents flow to and fro in the core, causing it to become hot and of course to waste energy. Okay, the current is flowing also in the iron core of the rotating thing, and that makes it becoming hot. And that is a waste of energy. These unwanted currents, called eddy currents, are kept small by making the core of thin strips of metal bolted together. I don't know what bolted means. So that each eddy current is quite small. We will see later how this reduces the heat production. Alloys are chosen for the material of the core which are even more suitable than iron in the magnetic properties, in having high permeability and low energy losses during the repeated change in magnetic conditions. Why are magnetic conditions changing? Because it's turning. Suddenly the North Pole and the South Pole, the poles are changing. But why is it changing back and forth? Let's go to read that part here again, the diagram. The diagram shows a single coil of wire. So a coil seems to be the name for wound up wire. The diagram shows a single coil of wire being rotated in a magnetic field. There's a magnetic field through two magnets at the side, and there's our single coil of wire rotating. This field exists in the gap between two pole pieces, which in a practical form of generator will be the poles of an electromagnet. An electromagnet. Okay, we have the two magnets, and each magnet has its line of magnetic field force to the outside. And exactly there, of the two magnets, these lines of forces are in the middle. There is our rotating coil wire. Every time it turns, it crosses the magnetic line of that one and the magnetic line of that one. As the coil rotates, a current is induced in it and is led away from the generating coil via. It's just a turning magnet? Or there has to be some type of energy? Now the question is basically, how easy is it to build a generator? And how much current can be produced? No, I don't know, I think it's called a dynamo on a bike. That is not complicated. It is a very tiny, quite cheap piece. And it can make, whatever it's called, a lamp burning. As the coil rotates, a current is induced in it and is led away from the generating coil via two rings which rotate with the coil. How much energy is produced with one turning? As the coil rotates, a current is induced in it and is led away from the generating coil via two rings which rotate with the coil. These are called slip rings. Pressed against these by springs are blocks of carbon cold brushes. The current produced alternates at each side of the coil, goes up through a magnetic field, then returns down through it, and so on. So here's a simple alternating current generator, usually called an alternator. In practice, an alternator will have not one but two, but many turns of wire in each coil and several coils, not merely one. You may remember what we said on page 44, that magnetic lines of force travel more easily in iron than in air, so you will appreciate why the coils of a generator are wound up on an iron core. The kind of arrangement shown in figure 41 gives some idea of how the magnetic circuit is arranged, so that the coils of wire move in a small air gap between the outer stationary part and the moving inner part. The rotating coil assembled is called the armature, and it is in the armature coil that the current is produced. Now we don't really understand it, but we can follow. That means that was the electrical engineering part. If you were here for electrical engineering, you can go directly to the next part of electrical engineering. If you stay here and participate in the shortened yoga, wenn es wieder die Augen ist. Feet are standing together, breathe in the outside. In and up. In and up. Out, out to the side. In and up. Out, out to the other side. In and up. Make an inch of space between the feet and up and to the side. Up and come up on the 10 toes. Out, sink down. In and up. Out, down to the other side. Heels down. In and up on the 10 toes again. Out and down, in and up. Reach high. Breathe out, hands down, feet together. Breathe in, bend the right leg. Breathe out, stretch your left one. In and change. And out and down. In into the middle. Out and down. Breathe in, lift the right hand up to the sky. Breathe out, bend the left knee, look over the right shoulder to the right hand. In and down. Out and down. Breathe and let the left hand. Breathe and let the left hand. Look to the hand and down again. Now make a hand with space between the feet. Breathe in and count down. And out again. In and down. Out and up. One more time, in and down. Out and up. Take hold of the elbows and gently rock from side to side. Hands again down, feet together, breathe in, come halfway up with a straight back. Out and down. In halfway up, straight back. Out and down. Breathe in, come up again. And intertwine the fingers and reach high. Breathe out, reach and roll all over back. In and up, intertwine the other way around. Out and in front. In and up. Draw the shoulder blades together. In and up. Hold with long arms back. Up. Out and down. In and up. Out and down. In and up. Bring the hands to touch and lower them down to heart center. That was my short and standing yoga. I thank you very much and until the next time.